Okay, we start now to analyze the volcanic jaspers, and in particular the group called Stratiform Jasper. And in the classification of jasper based on its precursor, volcanic jasper are that group that derive from the alteration of volcanic rock. So the volcanic glass that they vitrificate and form a jasper. So the volcanic environment, geological environment where this kind of jasper can be found is very variable, and there is many different possibility, but the variable are mainly three factors that are more important. The fact if the precursor is a tuff or a lava or an obsidian, that is a kind of lava. The fact if the alteration is in hot or cold condition, and if the alteration is subaerial or submarine. Both of the three jasper classified as volcanic jaspers are the result of transformation of glass in jasper through an intermediate passage that is opalcity. And stratiform jasper are that jasper formed in distal deposit in a bed, stratiform actually interbedded between fine-grained deposits that often have nothing to do with the volcanoes. So ash or clay distal from the volcano. And they are in bed that are broken in blocks, and they are submarine. The alteration so is cold. There is not input of hot water by fumarole. Okay, this is an example of a typical and very famous big jasper that is a typical stratiform jasper, and we can see the form of the block is squared, and the pattern is all around the block, and there is so the block say that was a bed that was broken in piece, and the precursor rock is fine-grained. There is no evidence of big structure inside, and the typical pattern is this dune pattern that is on the upper portion of the blocks, and the lower portion have more gray and or reduced iron color. This is another example of big jasper where is one of the best for the dune pattern. That for this reason it is very used by lapidary and by cutter because is what is called a landscape jasper. So the dune pattern that is typical of this group of jasper is not exclusive of jasper. This pattern is common in porous rocks. This is the very famous Canard Wonderstone from Utah. That is a rock often used for make slab decorative, but of very big size. And this is not jasper; is a sandstone, and is nothing to do with volcans. It's a fluvial sandstone, and in the same formation of the petrified forest of Arizona. Okay, how they form the dune? The dune is the result of a reduction of iron. So there is a redox surface between two solutions. One solution that bring oxygen that probably come from the uppermost and is of meteoric origin, and another solution that is rich of iron that can be oxidized by the other solution. So the contact of the two solutions form a redox surface, and and form this one of this line. So the repetition of the contact of the two solutions make continue new surface, and we can see the surface joined together in a more thicker line that is made of limonite that can be can isolate the solution, so it's impermeable, and when it's continue the new arrive of a new solution is impeded, so stop until this surface is fractured probably by desiccation, so it can enter and pass to a new phase, a new formation of a new dune. So this is the process, and it's very common in different shape in many rocks. This, for example, is the sandstone from Petra in Jordan, a very touristic place, and the rock have very nice pattern where all the tourists make pictures. This kind of situation is common in different geological environment. For example, in the bottom of a pond, when the pond is oxygen free, and each time there is a new arrive of oxygen, you have a line. The same can appear in a sea bottom, quiet sea bottom, with an oxygen situation. It is very possible that this kind of structure is responsible of a group of bacteria that are called iron bacteria. It is a bacteria that reduce iron, so they eat really iron, and they transform iron bivalent in iron trivalent, so iron reduced. And this kind of bacteria is common in pond quiet water, and they make like an algae carpet with iron color. And this is a nice cabochon of the dune pattern of Biggs Jasper. This is another Jasper from Oregon called the Shoot. This specimen is clearly nodular. In fact, this Jasper, because our submarine, can be nodular. And this is another the Shoot Jasper, but in this case it is blocky, it's fractured, but the pattern is all around the block. This nice cabochon of the Shoot Jasper. This is another Jasper from Oregon called Palomino, with nice landscape. And there is many Jasper in Oregon, is where lapidarists have found more variety of landscape Jasper, and most of them are of Stratiform origin. And this is the Cripple Creek, this Sucker Creek Jasper. Most come from East Oregon, the Hawaii mountain. And this is very interesting because you can see the primary lamination. This is the lamination original of the tuff that has been successively transformed in Jasper, and you can see the pattern is all around the block, that is always squared, but this thin lamination is clearly primary, and you can see grading of the thin lamina, and it's probably a fold deposit or a reworked deposit of original rhyolite tuff. This is another picture Jasper, where is very net the distinction from the bivalent iron color and the oxidized iron color here. And the rocky beauties are rare case where in some area it's possible to note coarse grained tuff. So this is the shape of original clast of the tuff, and we know that this is not in marine environment. It was probably in the bottom of a lake, because there was a caldera lake in this area, and this is a tuff deposited in the lake, and this is probably the pumice clast of the fall. It's a big slab, rocky butte, very nice pattern. The redox surface, the area of reduction of the iron, is follow water, and because it follow also the porosity of the rock. So more porous the rock, more the surface can enter inside the rock. So this is heavily influenced by the presence of fracture. You can see that the oxygen reach the rock going into the fracture, and this fracture is very evident that they've drained water for oxidized this group of dune pattern. So if you make the sum of the pattern from the edge and the pattern along the fracture, you can have a very complex landscape picture inside the Jasper. This is the Hawaii Jasper, is one of the more famous, and he commonly have both the structure around the edge of the block and along the fractures. This is another picture Jasper, blue Mustang. This another very similar, but with color more red, so more oxidized iron. Sunset Jasper, also very oxidized. This is chicken track. Chicken track is its name because this structure at the base of the beds that are the filling of the crack in the underlying bed that have a mud crack desiccation. So when you have the block, this look like a chicken track, and is a way for understand the polarity of the bed, because the track are the filling of the fracture, so are under the base. And this is a group of cabochon of landscape Jasper. There is a very big variety of Jasper in Oregon with this kind of pattern, but each one has its peculiar pattern and colors, so it's a huge variety. And since they are formed underwater, and at the same way as the flint, we have seen flint in the chapter about flint, that form nodule by boudinage. So it's a phenomenon of mobilization of the silica because of the pressure of the bed that overlie. So they can be nodular. So the fact that some of these jasper with the same pattern, the same color, can be nodular is a demonstration that they are formed in an underwater environment. So if we want to resume, stratiform jasper are formed in this environment, geological environment. We are fine tuff, underwater, distal from volcanoes, so underwater is and gold. The block are the result of the fracturation of a bed that are angular and squared. And we can clearly see that the pattern is formed after the fracturation. So the fracturation is early, the hardness is early, and the fracturation is after. So all the coloration and the formation of the pattern is after the fracturation. The dune pattern is characteristic of this kind of jasper, and the oxidized iron is on the edge and on the uppermost part, and the reduced iron is in the center and near the base. And also they can be nodular. There is a calcareo counterpart in Italy, the Paesina stone from Florence, very famous stones, landscape stones used for decorative purpose. And this is the outcrop of the Paesina, is interbedded in pelite deposit, is clay deposit, and the blocks are angular, same as Stratiform Jasper. There is oxidized iron around the edge and reduced iron inside and near the base. This is one of the lower deposit of Paesina stone, and also can be nodular. It's not so often, but you can see, for example, in this case the bed is closed in this direction. So the characteristics are all the same of the jasper, but this is calcareous. Only lack the dune pattern because the porosity of this limestone is very low, and so there is not sufficient porosity for the migration of the redox surface for make the dune pattern. So we can understand in this way something about the formation of jasper, about its geological situation.